Knowledge is important. Okay, so what I'm going to do then is go back to what I was doing before last time and do this rolling of the dice. What I want to show here is that as the number of dice increase, the distribution gets narrower and narrower, and the chance of getting an ordered state becomes smaller and smaller relative to the random states. So when I had 2 dice, I rolled the 2 dice for it to become statistical. But when I go and do 3 dice, and I said you have many, many ways. You have 216 arrangements, 6 by 6 by 6. And there are 216 ways I can roll 3 dice. They are constrained by their outcomes. How many ways can I roll 3 dice so I get an outcome? Okay, so when we go and roll those, and roll them, I'll just do 1,000, then you see that we have more possible outcomes, but these have a much lower probability of coming up. The point is, if you compare 3 dice with 2 dice, this is a steeper. There are more events which are random here than at the event. So if I go to 4 dice, there are 6 by 6 by 6 by 6, 216 times 6. All right, 10 dice. We roll those dice. You see, I'm getting 33, 39. Let's put in 5,000 to 5,000. Let's let it roll. It's rolling fast. And every time it rolls at the top here, every time it rolls here at the top, which are ordered, and the random states are dominating, and they're overwhelmingly dominating as the number of dice increase. Imagine if we had Avogadro's constant of dice. Here's the distribution. I think it was 50,000 rolls. I had 50,000 rolls here. And you see, it's quite a nice normal distribution. But in this distribution, in this 50,000 rolls, you never got one of these coming up. It's so improbable that it won't happen in your experience. So let's go to Avogadro's constant of dice. That's 10 to the 23rd dice. Okay? And I'm going to roll them. One roll, I got an outcome of, in this case. And so if I let the computer roll, that's what you get. You get a spike. I've gone from 2, 3, 4, 6, 10 dice to Avogadro's dice. So that's what happens. You just get. So I have 10 to the 23rd. And so this goes 6 to 10 to the 23rd. So what we got was this. We got this spike. But if you went down here and I magnified that, what you'd find is this. A little distribution, because this is called fluctuations.